the concentration of oxygen each day for a period of 5 days. So we will have 5 results. A starting concentration is 8, so CO is 8. The rate constant is 0.3. We have K. We need to use this equation to do calculation. When T is 1 day, and when T is 1 day, we can have these equations and calculate the concentration for the first day. The same as another 4 days. Here show the results of the answer of this question. Part 3 is about sedimentation questions. The first question in part 3 is about how to calculate the overflow rate, the setting velocities, and how to use this data to calculate the total removal efficiency. Let's read the question. We have the flow rate of 3 so this is Q. The size along with the percentage have been mentioned below in this table. The properties of the solids. We can use this data to calculate the setting velocity. And the surface area is 1.35. The first step is to calculate the overflow rate. We can use Q and A to calculate the overflow rate. Overflow rate equals to Q divided by A. Remember to change the units. This is per day, and we want to per seconds. Now we have the overflow rate. The next step is to calculate the setting velocities of different particles. Here we use Stokes' law. With this formula. In this formula, J is the constant, it's 9.8. Rho S and rho W is the density of particles and water. The density of the particle, we use specific gravity to calculate the density of particle. Specific gravity times 1000, and we get the density of the particle. Mu is the constant, d is the diameter of the particle. Take this one as an example. So remember to change the units. We want meters, not mm. So we calculate the setting velocities for the first particle, and the same as another two particles. The next step is to do the comparison. We compare the overflow rate and the different setting velocities. If the setting velocities is bigger than the overflow rate, then this particle can be removed completely. We have two if here. If the setting velocity is bigger than the overflow rate, then the removal ratio is 100. And if setting velocity is smaller than the overflow rate, then the removal ratio is Vs divided by Vo. We can do the comparison here. For this particle, the setting velocity is smaller than the overflow rate. So this particle cannot be completely removed. another two particles. They can be removed by this sedimentation tank. So we get the final answer of the question. The next question is about calculate the setting velocities using the Stokes law. You can have 1 minute